Thank you for telling me. Okay. Okay. So now please do like the question 1. They ask you to find a score test. And the rule is this. Okay. So you have to figure out what is the theta hand needle first and plug it to the equation of our needle. Yeah. The score test. Okay. Okay. Okay, let's go to question 1. So, score test. So let's copy the, so let's copy the formula first. Yeah. Okay. So let's figure what is the Sn and In first. Okay. So the first thing is we want to find the NIQ function. Is we have data. Okay. And this is equal to next product from I to N, and this. Okay. And sigma square. And notice the theta here indicates the two variable, like mu and theta. Yeah, mu and sigma. Okay. And exponential and 2si minus mu squared. Okay. Okay. And then we find a log likelihood, okay, which is the log negative like this, and this is the same. And also we can have the plus negative 2 sigma squared summation xi minus mu squared. Okay, this all looks good. Okay. Okay, and we want to find the derivative. So we need two derivatives. So the gradient of the log likelihood have two components. The first one is the partial component derivative with respect to mu, and another one is with respect to sigma. Okay. Let's say sigma square. Okay. Okay. So, and in the notation here, they define this one as Sn. Okay. This is Sn theta. Okay. And let's do continue. So the first two term is 0, and the next term is the 2 sigma squared Si. Okay. Yeah, it's negative. Okay. It's positive. Okay. And for sigma, yes, sigma squared. So the first term is 0, the second term is this. And the last term is the plus summation Si minus mu squared divided by this sigma squared to power 2, and it's the same. Yeah. Okay. So this is Sn. Actually we can derive the theta very easy because under the rule, the mu hat is, okay, theta hat 0 is equal to S bar and 0. Okay. Because we know the sigma, and also it's very obvious now the MLE is say for me. Okay. Okay, let's figure out what is the I theta. The I theta, we want to find this first. Okay. So this is a two by two matrix. Okay. Let's this one derivative with respect to mu, so we can get the negative sigma square n. Okay. And we derivative this with respect to sigma, so that would be negative sigma square and summation si minus mu. The the diagonal term is the same, and the off diagonal term is symmetry. Okay, so these two are the same. And the last term derivative with respect to sigma is equal to sigma square and become positive, so become this power 2. Okay, and this one we have to negative 4 sigma square power 3. Yes. Okay. Although it's like this. So it's x to negative 2. So derivative is negative 2x negative 3. So it's like this. Okay. And the I theta, by definition, is equal to negative this and tan the average. Okay. So you can see the first term is the same because it's a constant. And the last term is last is 0, and the of diagonal is 0 because the average of SI is mu. Okay. And this term, the average of this term, this is equal to sigma square. So the numerator is n sigma square. So it will be equal to, sorry, here is positive. It will be equal to n sigma square to the power 2 and 2. Okay. So it's like this. Okay. Okay. So this is a constant function, so it's not depend on the theta. So the key is so now we want to figure out what is this. Okay. And we know that the theta hat 0 is equal to s bar and theta 0 square. So Sn is equal to, and the first term is we plug in s bar. So it will be theta 0 square Si minus s bar square. This. Okay, and this is okay. Okay, and then another term is the n divided by 2 sigma square, plus the same term. Sorry, this is we don't have this. Why do we have to use S bar if mu is known? The mu is unknown. The sigma is known. Yeah, let me check again. Yeah, the sigma is known. Okay, mu is unknown. Okay, so when we want to plug in the sigma head needle, so this is MLE under the rule space. So the rule space is the rule space is equal to the sigma is fixed. So theta is equal to sigma needle, and the mu is unknown. So it's like this. It's rule space. And we want to find MLE under the rule space. And in this case, it's easy. We know that the sigma head needle will be S bar and this. Okay. So we pocket this into the scope function, Sn. Then we will figure out what is this. Okay. And you can see that the first term is zero because this term, this is zero. And the next term is equal to, yeah, it's this. Let's simplify this. Let's say this term is equal to nx squared. Okay. So it can be like the 2 sigma square n -1 plus sigma squared divided by sigma needle squared. Okay. And we plug in the formula. The scope function of n is equal to Sn. Yes. Okay. Because the first one is needle, so that would be easy. So it will be the inverse of this plus the square of this. So the inverse of this term is n. So it will be like the n 2 sigma needle square s square sigma needle square minus 1 square, and the distance is n 2 square. Okay. Yes, I think everything makes sense. So you can we can get rid of this term and this term and 1 of theta, so it can be minus 2 square. Okay. Okay, I think this makes perfect sense. And it will be follow the class square one. Okay. Okay. Any questions so far? Yeah, I know the finding the score test and all the wall test will have a lot of calculation, but it's not hard, so you just make sure you did. Yeah, you make sure you did all the steps right. Okay. Okay. So I'll give you like 5 minutes to look at the question 2. So this is a similar question. We want to find a commutable and by evaluating the likelihood ratio test and the wall test. So okay. For mu, so in this case, we will under the rule that look at this. We want to inverse the hypothesis testing when mu is equal to mu zero and like the mu is not equal to mu zero. Okay. So in this case, mu is known. Okay. But sigma is unknown. Okay. Okay. Okay, let's go to question 2. Okay, so when we want to invert the confidence level, when we want to find a confidence interval by inverting a hypothesis, first you have to define what's your test. Okay. So we want to invert mu, so the test maps must be look like this. Okay. So the mu is the phi is unknown. Okay. Okay. So let's do question 2. Let's do the word test first. Word test. And what is the test is look at this. Okay. Okay. Let's copy the formula. Okay. We want to transform our hypothesis to the albedo. So to function R, so it must be look at this. Mu minus mu naught equal to 0. Mu minus mu naught not equal to 0. So that means the R theta is equal to mu minus mu naught. Okay. So if you want to find C is a derivative of R theta, so that would be the C theta will be 1 0. Because the theta have 2 parameters, if we derive it with respect to phi, it will be 0. The S is final double mu and phi. And we can derive the theta has. We know that under the likelihood, the MLE is the S bar and sigma square. Okay. Where the sigma square is equal to okay. So this is theta hat. Okay. Okay. So this is the theta hat is MLE. So all we need to know is what is I theta. Okay. What is IN theta? Okay. And we derive the IN theta in the question 1. So we can use this. This is equal to, because they are all normal distribution, so the I theta is the same. Will be like this. N divided by sigma square. 4. Okay. I should use phi, so it's phi square. Okay. Then we plug in the formula. So Wn is equal to mu minus so I want to plug in a theta hat, so it's S bar. So it's S bar minus mu naught transpose. This is a C theta, so it's 1 little transpose in theta inverse, so it's equal to the inverse of this, n phi 2 phi squared, and 1 little, and then we want to find the inverse, s power minus mu naught. Okay. So it's equal to s power minus mu naught square, and this is equal to phi n. Sorry, the phi should plug in the head, so this is should be s power 4. So this is s square s power 4. Okay. So it should be ns squared. Okay. Okay, so this is looks very nice. So this is just a square of t test. Okay. So square test. Okay. Okay, so let's watch test and let's do the liquid ratio test. So we want to find liquid ratio function first. Find ML. The liquid ratio test is you find the log liquid ratio. Okay. So we want to find liquid ratio test. Find negative this. Okay. We know this term is equal to like a log the numerator divided by the denominator. So it can be like the L, can be the theta hat nino minus L theta hat. Yes, that's very true. Okay. And we know that the theta hat is equal to s bar s squared. And theta little hat is equal to so theta little under the rule, so mu is equal to mu naught, so it's mu naught. And let's say this is s naught squared. And s naught squared will be the si minus mu naught divided by. Okay. Then we plug in these two estimates to the local IQ function. Okay. And L theta will be, I think we have this in the question 1. It's this. Okay. Okay, this is L theta. So the L theta hat zero minus L theta hat is equal to this. We can cancel this term, and this term is different, so it will be negative 2 log theta hat here is theta zero hat theta s zero square plus minus 2 this will be s zero square summation si minus s bar minus mu naught square. Okay. And it's also the same term. Minus s square. Okay. And we know that this is equal to ns0 square, and this is equal to ns square. Okay. So then we will have, then we can cancel these two. Okay. And it's the same. So in the end we will have like the 2 the log s squared divided by s0 square. Okay. Yeah. Yes. Okay. So the negative 2 log negative ratio will be n negative n log s squared s0 squared. Okay. Okay. And then you can find a common interval. So we will be, it will be follow the chi-square 1. So the common interval will be, look at this. We find a set region, so it will be like s0 square smaller and greater chi-square 1 half over 2 chi-square 1 over 2. Sorry, that is usually we tend to reject if this is large, so the S region will be like, look at this. Actually, yeah. So this is a set region, and we condense all the mu naught, satisfy this, so this is commutable. But actually, if you do a two-sided, it's also fine. Just not okay. Okay, next question to you. Any questions so far? Okay. Okay, let's go to the last question.
Sorry, actually, can I ask a question real quick about question 2?
Sure.
So, if we had a question like this on an exam or homework,
yeah,
would it be appropriate to leave it in this form? Or would we need to like show explicitly that it's an interval or like solve for mu or something like that?
Okay. I see this question, they say you only have to find a confidence set.
Oh, confidence set. Okay.
So you don't have to show it is a interval. Yeah.
Okay. But if it asked for an interval, we should show it's an interval.
Yeah, you have to figure out if this is a increasing function in mu, and you can say it's a interval. Yeah.
Okay. Thanks.
Yeah. So the question will tell you very clearly what they want. So yeah, then the set is important. Yeah. If it's an interval, that would be more discussion. Yeah, so this one is fine to show its interval, because if you find this will be a polynomial with order 2. So in that case, it's easy to say it's an interval. Yeah. Yeah, that's a good question. Yeah. So Yeah, I think yeah, how to find this test is very important in the final. Okay. Uh, we have the 25 minutes. Okay. I give you another 5 minutes to look at the question 3. So for part A, you have to use the hint. Yeah. So you have to show that the moment generated function is converged to the more generated function. Okay. Okay, let's go to question 3. Okay, the first part is we want to show that we have this as a topic. Then we can use this as a topic to find a commutable. Three. S1 to Sn, they'll follow the negative binomial gamma and p. So the y is a summation of x. So at y will follow the n gamma p. And we want to prove that the 2y gamma, that's true. The 2p gamma, 2py, 2py will converge to chi square 2n gamma as p go to 0. Okay. So let's find the homogeneity function first. So we know that the homogeneity function of the chi-square is look like this. So let's say this variable is z. So the homogeneity function ng, let's say ng, let's say nzt is equal to the homogeneity function of z. So it will be tz. Okay. So this should be equal to 2n gamma. So we plug in a 2n gamma to, I think this is a typo. So this should be k. So it's negative k. The degree of freedom, so 2n gamma divided by 2, so it's n gamma. Okay. And we find the homogeneity function of this. So the homogeneity function of 2py t. So it should be like the exponential of the 2pty. So they can be, so we can say this is a function, and this is a, you can say this is t. Okay. So we can plug in the formula, which is 1 minus p 1 minus p e to the power t to the comma. Okay. Okay. So we will have the p is the same. 1 minus p is the same. E to the t. T is 2bt here. And the y will follow the gamma is n gamma. It's n gamma. Okay. So we want to show this converges to this as p go to 0. Okay. So actually we only have to show that the p 1 minus p e to 2pt converges to this. Okay. So it is surface. Okay, so now we have this, and so we want to find this. You know. For this, I want to apply the no no p-task theory or lemma. Okay. So we can, this is equal to the p go to 0, the derivative of the numerator is 1, and for the denominator is 0 minus negative 1 e to 2pt minus 1 minus p e to 2pt and 2t. Yes. And when let p go to 0, so p is 0, so this is 1. This is 1. Okay. So we will have the, and p go to 0, this is 0. So we can have the 1 minus 2t. Okay. Okay. So because the homogeneity function of the 2py converges to this, so the 2p1 will converge to the chi squared to n gamma. Okay. Okay. Distribution. Okay, so that's question A. So we can have the, we can use the chi square approximation. So for B, we want to control and confident interval. So we can say this is follow the chi-square distribution. So the accept region can be look at this. And we want to collect all the P, satisfy this. Yeah. Okay. So we can do some rearrangement. So it can be like the P is 2y. 2, 1. Okay. Okay. And the next question. Okay. I see the next question is the most important one. This one. We want to find the minimal length of 1 minus alpha commutative based on the asymptotic pivotal 2py. Okay. So this means from the pivot, the pivot quantity, we can know that the conduct state will have this relationship. Will be look at this. Okay. And this is the first condition. The second condition is the they had to satisfy the probability is alpha. So that means the integrates from A to B, and if this is 1 minus alpha, and this is the distribution of the chi-square. So we have these two conditions. Okay, so it's Q3. And we want to find a minima that's under these two conditions. Okay. Okay. Yeah. So the length will be B minus A divided by 2y. So this is length. The constraint is the condition is okay. And we want to find B and A. Okay. So okay. This is equivalent to B minus A. Okay. Because the Ty is the same for all the B and A. Okay. Okay. So then will be we want to find the minimum of B minus A. The condition is constraint to this. Okay. Okay. The way to do that is I want to show to next the B to a function of A. Okay. So we let B is equal to function of A. So B is function of A. And we can find the derivative of the condition. So next dA of A, B of A, F Z Z D Z. Okay. So this should be 0 because this is constant. So that would be like the FZ B of A, B prime of A plus a minus F Z A equal to 0. So for this, we can find the derivative of the B prime of A. So B prime of A is equal to FZA divided by FZB. Okay. And let's go back to the optimization function, B minus A. So the B A minus A. So this also should be 0 because we want to find the what's that the critical point. So under the critical point, the first derivative should be 0. So this is equal to B prime A minus 1. So our condition will be B prime A equal to. So that means the B prime A should be equal to 1. Okay. So and B prime A also should be equal to this. So that means combine 1 plus 2, we can guess that the should be 1. So next can be FZA equal to ZB. Okay. So this is condition. Okay. Okay. So you can draw a graph like the density of the z will be look like this. And we want to find a truncation line such that the left tail and right tail is the sum of left tail and right tail is one. Such that we can say this area is 1 minus alpha. Okay. Okay. Mm. Okay. So the answer will be the 1 minus alpha common row is equal to, you can say, look at this. We connect the P, and the P should be equal to this and this, and these two are the same. And also the other condition is the integral AB should be 1 minus alpha. Okay. Okay. So I think that's the question 3. Okay. Any questions? I would say how to find the minimal left countable is very important. Okay. So you can use this technique to find the countable. Okay. To find, yeah. Okay. So if you don't have a question, I think that's today's discussion. And let me know if you need any help.